Hi, my name is Adrian Bumann and I'm presenting the submission 46, predicting the spread of invasive marine species with open data and machine learning, process and challenges. To give a background, invasive species are a major challenge and have negative impacts on economic, environmental and social levels. And in the past we've seen increasing amounts of open data, as well as technological advancements in AI and machine learning. And this submission is an overview of one use case using machine learning in the marine context. We focus on one particular species, which is dubbed the killer shrimp, due to its negative impact. The question we want to answer with machine learning is, how does the shrimp spread in the Baltic Sea under different conditions? This is an overview of the data we used for this use case. As you can see, it comes from a variety of sources and covers different important features. And once we had this data, we started the process. And first we compiled the data and then we had to clean the data. And the next step after that was to address the high imbalance between presence data, which we had 3,000 data points for, and the absence data, which was almost 3 million. The challenge there is that a naive classifier would easily reach a very high accuracy, because the naive classifier would just say that every area in the Baltic Sea has no shrimp available. To address this, we aimed for more false positives than false negatives. And to evaluate this balance between the two, we used the metric AUROC, which stands for Area Under Receiver Operating Curve. We used different machine learning models. On the one side, tree-based models, single and ensemble. These are especially suitable when you have no previous feature selection or pre-processing, and they are comparatively easy to interpret. We also used a deep feed-forward neural network, which is able to capture more complex features than the tree-based models alone. And the results you see on the right side. The neural network has the best performance out of these. And you see that the tree-based models have a higher F1 score. This is because they tend to predict the majority class. And once we had that, we evaluated our results. And since we used raster-based data, we could make a prediction for every cell in the raster grid. And we found two areas in particular that were found suitable for the spread of the killer shrimp. One, the area of Åland and the region of East Sweden. We used the free platform Heroku to create this visualization you see on the right side. That has become very useful for people to understand what the model does. And we published all the code on Kaggle and GitHub. Challenges we found: the data is siloed on a lot of platforms and it can be tricky to navigate them when you're not familiar with them. Once you get the model predictions, it can be very easy to be overconfident, and you should always consider the context of what the model tells you. A lot of the data had different coordinate reference systems. For this we found some very helpful Python packages, and also the general context of the invasive species has a lot of influencing factor. So it's not always easy to first understand the context fully and also to gather all the relevant data. In the end, you always have to simplify the problem a bit. As a conclusion, this was a very interesting showcase. It shows that machine learning in the marine context has potential. And the biggest challenge is not really building a machine learning model, but the data. To find it, to understand it, to collect it properly. And in this case, the model we built, it doesn't have really practical use because we used some assumptions for the model, which may not be completely realistic. To give some recommendations for other people trying to do the same, I would suggest a smooth collaboration and communication between data and marine scientists, And for data providers, it would be helpful to have aligned and uniform documentation standards to make it easier to navigate and find the right data. Thank you very much.